afternoon, everyone. Welcome to AFB Scotland Real Projects event titled HAZOP Fundamental Study. My name is Oluwatoyin Fatokun, and I'm the Deputy Real Projects Coordinator. I'm delighted to be your host for this talk. And just to go over briefly the format of this talk, it will be in two parts. There'll be part one and part two. There will be some questions, we're trying to make it interactive in between it, and we'll have a short break in between part one and part two. There'll also be hopefully a doodle pool session just to understand people's level of experience with the HAZOP. And a bit about Cassie. Cassie is one of us in AFB, is actually the Real Projects Coordinator, so I handed over the baton to myself. He's a chartered safety engineer, safety and risk engineer, who has a wealth of experience spanning over 17 years. He lives in the UK, he's worked in South America and Middle East. He has a wealth of experience, and he will, I'm just going to hand it over to him to continue. Cassie, over to you.
Good stuff. Very flattering introduction there, Tony. Thank you very much. Hi everyone, welcome to this webinar. My name is Cassie Usani, and as Tony mentioned, I'm a safety and risk engineer. I've got a decade and a half of experience in the industry as a safety engineer in various jurisdictions as well, including the UK. This webinar is a repeat of workshop that we held that I conducted about 3 years ago, 2017, I believe, pre-COVID-19, where we had obviously able to make contact with people. And the picture that I've put up here on the third slide shows where we were at that workshop. Now, this workshop, as Terry mentioned, is going to be in two parts. Part one, look at the objectives that seminar, the types of HAZOP, what the HAZOP is compared to other risk assessment techniques, why and when we should carry out a HAZOP, and we would also have an exercise. We'll have an exercise at the end of that part. And after that, we'll have a 10-minute break and return for part two. Part two will cover HAZOP planning and preparation, and HAZOP recording, management, and closeout. And we'll have a final exercise if time permits. Looking at good versus poor, HAZOP recording. Obviously, we'll then conclude on some final takeaways and questions. In terms of aims and objectives, we've said, we even learning outcomes from this webinar. We can potentially learn the difference between a HAZOP and other risk assessment techniques. Know when a HAZOP is required. Is it really a HAZOP that you need? Be able to plan and prepare for a HAZOP. Know what and whom you need at the HAZOP, and be able to participate in, record, and report a HAZOP. In terms of HAZOP definition, so I've taken a definition from the standard IEC 61882. That's the standard for HAZOPs. So a HAZOP study is a detailed hazard and operability problem identification process carried out by a team, and it deals with potential deviations from the design intent, examining their possible causes and assessing their consequences. There's an alternative definition by an anonymous person, cheeky definition, that says that a HAZOP is a detailed hazard and operability problem identification process, sometimes carried out within difficult time and resource constraints on a design that may not be fixed, and by a team, members of which have never met one another and have different degrees of ownership and interest in the process. They are led by a facilitator. They have little facilitation experience for a customer whose expectations may not be there, different from what we know. Goes on to say that the HAZOP deals with potential deviations from the design intent, examining the possible causes and assessments of their consequences in a creative brainstorming process, the effectiveness of which depends on the manner in which the technique is applied. which cannot be measured in any scientific way. Now, looking at the first part of this second definition, what we find reading between the lines is the challenges that we are likely to face in both the organization and the conduct. Things like difficult time constraints and resource constraints. It may not have been budgeted for. Sometimes you may not have budgeted for the HAZOP, and then you find that you need to do one. Not enough time to do one. Sometimes the design might not have reached a sufficient level of completion, or may not be fixed. So they are moving. It's a moving target of a design. So things changing, design parameters changing, by the day. And you're supposed to be developing that. The members of the team may never have met each other. They may not be working in one section of the team. So sometimes external people might be coming in to do the HAZOP, to things in the HAZOP. And then people have different agendas, if you like, for attending the HAZOP, different things and different levels of ownership and interest in the process. And then sometimes, possibly because the people may not be experienced enough or competent in the HAZOP. So those are sort of the challenges that we are hopefully going to try and going to look at during the rest of the webinar.
Okay.
Yeah, he doesn't like that definition.
Today we're having a real projects webinar. It's on HAZOP Study Fundamentals. So just as a bit of background, I conducted this workshop, a similar workshop some years ago. I think, Olive, correct me if I'm wrong, I think it was in 2017 we did this. So it was an all-day sort of Saturday like this. We all sat in a room, couple of folks, well, not more than a couple of folks, about 20 odd, 22 odd folks in the room, for the whole day doing this workshop on HAZOP. So there we were able to do case studies and learn about what HAZOP's are about. So today's webinar basically is a scaled down version of that workshop that we had. With COVID-19 coming our way, we are not able to do things obviously as lavishly, if you like, as we would normally do. So we'll just have to make do with this presentation. I've got two exercises, as Toyin mentioned earlier. The first exercise would come up. Well, first of all, the presentation is in two parts. The first part will be the intros and all the, if you like, just learning about HAZOPs in general, and then we'll have a break. We'll have a 10-minute break. Prior to that 10-minute break, I've got a little exercise that we'll do, which is the first exercise. And then after the 10-minute break, we'll go to part two, which is a bit more of deep dive, if you like, into HAZOPs. And then we'll have an exercise at the end of that as well. And we'll end with questions. But in the meantime, if you've got any questions, I think Toyin might have mentioned earlier, so just type your questions into the comments box so I can see them when we are starting. Then I'll take them one at a time. Hopefully that's all right by everyone. So if you've got any contributions as well, it's not just questions, obviously, because I am hardly the expert at this thing. I've got quite a few. I suspect that there's quite a few experienced folks in the audience. So by all means, if I get anything totally wrong, feel free to correct me, please. So yeah, put your comments in the comments box and contributions and observations as well. I appreciate that very much. Thank you. So in terms of agenda, I think I've touched on that already. So we'll talk about the aims and objectives, which I think is on the next slide, aims and objectives of this session, the HAZOP study session. We'll learn about what a HAZOP is, compared to other risk assessment techniques. So obviously, as you know, a HAZOP is a risk assessment technique, one of many. And then we'll talk about the types of HAZOP and when they can be applied, or and when it's appropriate, if you like, to do a HAZOP. So that's the next bit, why and when to carry out a HAZOP. And then we'll do the exercise that I mentioned earlier and have a 10-minute break. When we get back after the break, we'll get into the HAZOP planning and preparation, talk about the recording, the management, and the closeout of the HAZOP. And then we'll do that last exercise, which is on good versus poor recording of HAZOPs. And then we'll have a conclusion and takeaways, and then questions, obviously. Right. that's where the doodle poll was going to come in. I think I'm just going to pass over that. Hopefully we can sort that bit out later, and I'll get a feel for, the experience levels in the audience, experiences with HAZOP. So I put this photo up here. As I mentioned earlier, this is a repeat of what we did some years ago, and that was me at the workshop. So that was us doing the exercise, actual HAZOP study exercise at the workshop. That's a picture of us at that workshop. Just give us a feel for when the times were good, pre-COVID-19. Right. Aims, aims and objectives. So the first there is we aim to know the difference. We're trying to know the difference between a HAZOP and other risk assessment techniques. Would know when a HAZOP is required. Is it really a HAZOP that you need? And then hopefully we can plan. We'll be able to plan and prepare for a HAZOP. Know what and whom we need to attend a HAZOP, and be able to participate in, record, and report a HAZOP. So those are the key sort of objectives that or learning outcomes, if you like, that we've got for this session. Now, what is a HAZOP? So I've taken the standard definition out of IEC 61882, which is British standard for, the standard for HAZOPs and risk assessment, other risk assessment. So a hazard and operability problem identification process that's carried out by a team. The key bit there is it's in a team. It's not a desktop exercise, a one-man desktop exercise. And it deals with potential deviations from the design intent, examination of their possible causes, and assessment of their consequences. Now, there is another definition, another cheeky definition of a HAZOP, which someone has given in the past. So someone has defined a HAZOP as a detailed hazard and operability problem identification process, sometimes carried out within difficult time and resource constraints on a design that may not be fixed, and by a team, members of which have never met one another and have different degrees of ownership and interest in the process. Now, they are led by a facilitator who may have little facilitation experience, and for a customer whose expectations may not be clear. So HAZOP deals with potential deviations from the design intent, examination of their possible causes, and assessment of their consequences. In a creative brainstorming process, the effectiveness of which depends on the manner in which the technique is applied, but which cannot be measured in any scientific way. So yes, there's nothing scientific about the HAZOP, to be honest, in terms of how it is carried out. It is all about, mostly about, man management, being able to work together in a team and being able to, put our clever thoughts together to brainstorm problems and come up with, brainstorm and evaluate problems and come up with solutions or indeed actions. The first bit of that second definition there is, if you look at it, if you read between the lines, what it actually does is tell us the challenges that that are faced by persons who are either organizing HAZOPs or facilitating or chairing HAZOPs. Difficult time constraints on a design that may not be fixed. So you're carrying out a HAZOP and things are changing. The design is changing virtually by the day, and you are supposed to be HAZOPing that. And then you get together, in the HAZOP, you've perhaps not met anyone, in the team at all. With, different people have different levels of ownership, and so they are not able or willing to take responsibility for certain things that come out of the HAZOP. And of course, sometimes a facilitator may have little facilitation experience, and I've seen that, seen that quite a bit as well. And sometimes the customer or the client as well may have different expectations or very, very, if you like, strenuous expectations that are not achievable. So those are some of the challenges that you find with HAZOPs, which I'm not going to claim that we're going to try and solve or learn a lot about all of those challenges today, but we'll touch on a fair bit of those as part of this this session. What are the key features of a HAZOP? One of the first ones that it's quite structured. Of all the risk assessment techniques, it's probably the most structured. In terms of the guide words, the documentation requirements, the recording, the management, and the closeout, it's very structured. So the guide words are fixed. It's very difficult to do a HAZOP with a different set of guide words than what we know, which we'll touch on later, than what we know to be the guide words for a HAZOP. It's very structured in that sense. When the recording and the reporting of the HAZOP, likewise, it's all very structured if it's going to meet the quality requirements for what a HAZOP is. It's facilitated by an independent and, I put in brackets there, a competent chairman. So the independence is quite critical. So because to chair a HAZOP, you've got to be, if you like, not a part of the design team. You've got to not have any sort of responsibility or accountability for the design itself or for the project. You've got to be very independent. Obviously, you've got to, in the process of preparing for the HAZOP, you have to learn about the process that you're going to be HAZOPing, but that is the extent to which you get involved in the design. You are not to be involved in the design at all. And the reason for that is to make sure you are almost if like a third eye looking in, and therefore being better able to identify issues with the design, identify the hazards and safety issues that might result from the design. So that is the key intent. You must be independent of the project, not have accountability or responsibility for any aspects of the design. So the other feature of HAZOPs is the timing. The design must be sufficiently mature before HAZOPing. So you don't want to do a HAZOP where you've still got, so just to track back a little bit, one of the key reference documents or reference materials for a HAZOP are P&IDs. I believe we are mostly all familiar with P&IDs, process and instrumentation diagrams. And that's the key, if you like, currency, for want of a better word, for a HAZOP. And sometimes, for you to do a HAZOP at all, a worthwhile HAZOP, those P&IDs have to be, if you like, frozen at a certain stage of the design, depending on what phase of the project that you are at. So the design via the P&IDs has to be sufficiently mature. Otherwise, you're probably either likely to truncate the HAZOP midway. It might become something different from a HAZOP, just because we're talking about so many design issues that should already have been, finalized or completed on the drawings. So the timing is quite critical, and it must be, targeted at when the design is as complete as it can be, whilst still allowing time for the HAZOP to take place. Because obviously, after the HAZOP, it is in all likelihood you might have to go back to revisit aspects of the design or the drawings. So it's a balancing act, but the timing has to be targeted more towards the tail end of design completion. It's a relatively cost and schedule intensive event. It can take days depending on the facility or the modification that you're HAZOPing. It could take days, it could take weeks. I mean, it's difficult to see. I don't think I've been in a HAZOP that lasted less than, well, I have been in a couple. When you're HAZOPing, maybe the odd single sort of line here, just doing, but it's difficult to see a HAZOP lasting less than one full day. It's not standard. It's more weeks. If you go into months, I've been in a HAZOP that went 3 weeks. I haven't been in one that went over a month, but I've been in one that went 3 continuous weeks. That's when you're HAZOPing perhaps an entire facility or all that. And of course, time is money because you've got a team of people, expensively paid engineers sitting in a room for 1 week, 2 weeks, 3 weeks. So yeah, it's cost intensive as well in that sense. And the other feature, I guess, is that it's often used as a HAZOP is often used as a design assurance milestone to verify that a process design is fit for purpose and safe, if you like, in the sense that you've done a feed or detailed design, and you want to have something that says, right, this design that we've completed either at this feed stage can pass muster, if you like, is well designed and it's safe and it's safe to operate. So that's what a HAZOP must. It's a very, very major milestone when you are doing your design assurance at the end of a design phase. It's one of the key things that gets listed, obviously assuming that the project is one that required a HAZOP to be carried out. So the HAZOP is usually listed as one of the assurance steps that have to be checked one way or the other, checked to say, yes, you have carried out the HAZOP, or checked to say, or justification to say you didn't need to do a HAZOP for that. So it's a major design assurance milestone. So check that your design is right and good. Finally, on that one of the features is that it's a key reference document in process safety, accident, and incident investigations. I think what I should have added there as well is that it's a key reference document for plant. I think we'll touch on that on subsequent slides, but it's a key reference document for even plant operations. If, for example, there was an accident or an incident relating to the process, a process safety incident, the HAZOP is one of the first documents. The first question that's usually asked is, was this process HAZOP? Can we see the HAZOP report? And that's where the investigation, well, after the initial sort of talking to people and everything, as far when you start the more forensic investigations, one of the key documents that you'll be looking at is the HAZOP report to see how the process was. If the process was HAZOP, was it HAZOP properly? Where was that particular hazard, that resulted in the accident or the process safety incident? Was that identified at the HAZOP, and was it addressed? So a HAZOP is quite critical for that purpose, and for that reason alone, if nothing else, the quality of the HAZOP report. I think we'll touch on that later. The quality of the HAZOP report, the recording, must be such that it can withstand the kind of scrutiny that would come should, there be a process safety incident investigation or anything similar. Okay. Right. Here we look at what a HAZOP is versus other techniques, other risk assessment techniques. So obviously the HAZOP is the features of the HAZOP are listed on the left, and the other techniques on the right there. HAZOP is mainly used on process fluid systems. So you wouldn't be doing a HAZOP on, say, an electrical system or what's it? So fluid systems would be obviously hydrocarbons, which we in the oil industry are familiar with. Hydrocarbon systems, crude oil, gas systems, just even seawater, even plain seawater, hot water systems. What else? Plant air systems, and all of those are all fluid systems. And one of the key characteristics, if you as you might have already gathered, is that all of these are contained within a system of either piping or vessels or something. So the key thing to remember, if nothing else, about a HAZOP is that it looks at fluid systems within a containment system, be it piping or vessels or valving or whatever, as opposed to the rest of the plant outside of that system. So that's one key feature of HAZOP, of where HAZOPs are required. Remember that. I think I'll give you a tip. The exercise that we do might touch on those sorts of things. So in terms of other risk assessment techniques, so for example, your hazard, your SAFOP. So the SAFOP is I think we know what the hazard is, but SAFOP is the safety and operability study, and it's mostly used for power and electrical systems. In fact, it's the if you like the HAZOP for those sorts of systems, for electrical and power systems. The HIRA, hazard identification and risk assessments, sometimes mostly actually used for marine systems, be used for any other thing as well, actually. The FMICA, failure modes and effects and criticality analysis, the task-based risk assessments, etc. So those are the other types of risk assessment or hazard identification techniques that are available. And by the way, by way of a reference standard for this sort of risk assessments, so the standard that I'll refer you to is the IEC 17776. IEC 17776, I believe, is the standard that sort of covers those types of risk assessments. I haven't used it here directly, but I just seem to recall that a standard that touches on this. So the other risk assessments are mostly used for work activity or plant or project-wide hazard identification and assessment. If you recall from what I said, SAFOPs and hazards and HIRAs are used for. So those are the sorts of project activities, if you like, that you use the other techniques for, as opposed to process fluid systems, which the HAZOP is used for. The objective of a HAZOP is usually to prevent loss of containment resulting either from process-related excursions from the design parameters or design intent, or mal-operation of the system. So excursions, excursions being either basically it's another word for departure from what the design intent was, higher temperature than the design temperature, or higher pressure, lower pressure, whatever. All those excursions from the design intent and from the design parameters is what a HAZOP looks like. In addition to that, it's the human factor, which is mal-operation of the system. So the HAZOP looks at all of those things together. Whereas other risk assessment techniques are often used as a means, actually, to help identify subsequent risk assessments that may be required. So typical for that is the hazard. The hazard most times, because it's higher level, looking at things from a much higher level, it leads you into doing other studies, which if there's any safety engineers in the audience, as I'm sure there are, Justin, you're there. So hazard would lead you to maybe do things like a dropped object analysis, would lead you to do a fire risk analysis, for example, or lead you to do QRA or whatever. So likewise, the SAFOP, the other ones, the HIRA and the TBRA, are more granular or lower level risk assessments that you apply at the tail end of a design, and yeah. So that's what the other risk assessments are used for. Now, the HAZOP is more onerous or has more onerous and mandatory prerequisites and execution requirements. For example, the competency and independence of the chair and the core attendees, the P&ID, revisions, etc. Talked about P&IDs earlier, the major currency of HAZOPs. So the revisions of P&IDs, the state of completeness and completeness of the P&IDs is very, quite important for a HAZOP. And the independence and competence of the facilitator. We touched on it at the definition there, the challenges. So that's all very important. The attendees that are required at the HAZOP, that's all quite, those prereqs. Those are prereqs that you must have for you to have a good HAZOP accord, to be honest. The other requirements for the other risk assessments are less onerous, and the execution requirement, they are just handled as part of project execution activities. And yeah, obviously you aim to close out all the actions that might come out of those and do everything that's required. But in terms of the conduct of those risk assessments, I think the requirements are quite flexible, if you like, depending again on the actual project or the design or plant, even that you're dealing with. The HAZOP guide words and deviations are very consistent. I mentioned at the start that those guide words do not change, don't change at all. However, for the other risk assessments, guide words were used because yes, can be mixed and matched to suit the purpose. So, for example, you have a situation where you have a design that is not quite a HAZOP. Perhaps you have a control room modification that you are doing that involves a lot of work on the panels, control panels. You have air system, instruments, systems feeding in, and all of that. And you need to find a risk assessment to do that, suits that. A SAFOP, for example, by itself wouldn't do the business. A FEMICA by itself wouldn't do the business. So what I have done in the past with that sort of scenario is I've actually mixed and matched the guide words for some of those risk assessments and used them to achieve the objective which I want to achieve with that particular with the risk assessing that particular project. So you can do that with the other kinds of risk assessments, but not with the HAZOP. The HAZOP guide words are very consistent. So the HAZOP typically has fewer participants. At least it should have fewer participants. The reason being, you should keep the team as small and sizable as possible with just the core participants. The core disciplines are required. That way, you're more likely to be you're going to be more productive, I think, and keep things in better control, because it's not easy enough to chair a HAZOP, never mind having a whole room full of people to try and manage. So you want to keep the team as small as possible. Whereas the other risk assessment techniques, you might have an entire project team, in a room doing a hazard, doing a SAFOP, or doing a TBRA, or that's the difference. So the last bit there on the HAZOP is the reference documents, the P&IDs. You can't have a HAZOP without them. I don't know of a HAZOP that you can do without P&IDs. So, but for the other risk assessments, the reference documents can be anything from plot plans, PDMS model, method statements, survey reports, asset safety. You can use just about anything that's available and that's amenable. Cause and effect charts and everything you can use to do those risk assessments, just as you require. Good. So, how are we doing for time? I hope I'm not taking too long because we've got some.
No, you're still doing it. Thanks.
Very, very good. Right, HAZOP application. When and why should we do a HAZOP? So I've put some examples here of scenarios or design scenarios where you might, question, do you do a HAZOP or not? The first bit there, identifying potential hazardous events and operability problems on new process facilities. So you have a new process facility and you want to identify hazardous events. You certainly would need to be doing a HAZOP for that one. Identifying latent hazardous events and operability problems on existing process facilities. Yes, again, I think you'll definitely be needing a HAZOP for that one. Checking a process design for compliance with standards. That's a definite no. You don't use a HAZOP to do to check for completeness of a design or compliance with standards. That's what you end up having is what you need, and what you end up having if you even try to do a HAZOP is a design review. What you need to be doing is a design or P&ID review or whatever. In any case, the design should already be compliant with all the standards, all the standards, applicable process standards and everything before you can HAZOP. It's not what a HAZOP is for. Evaluating design alternatives, yes, possibly. So you have a project that's at concepts, at study stage, concept selection phase, and you're wondering, should we use, say, for example, two 100% heat exchangers or 4 50% heat exchangers, just as an example. And So a HAZOP, you decide to do a HAZOP on both of them to determine which of them has more risks or more hazards associated with it based on your plant's configuration. You might be questioning at the concept stage, should we have 2 compressor trains or just 1 compressor train? You might decide to do a HAZOP to determine which of those, from not just a hazard perspective, but from an operability perspective as well. A HAZOP would help you as well in determining which of those configurations you should go for at the very early stages of the design. So at the concept stage, so it helps you with your concept selection. And you'd be doing a very coarse HAZOP at that stage because obviously you don't have, as we said earlier, mature PNIDs, to use, but you'll be doing what you have. You can even use the PFDs, just walk through the PFDs, process flow diagrams, that is, and whatever PNIDs you can knock up at that early stage of the design. You use those to do a course HAZOP, determine what configuration is best for your project or for your design. If you're carrying out routine drilling, workover, or pipeline operations, no, HAZOP wouldn't be suitable for that. It's not very cost effective. So if it's routine drilling operations, I mean, well engineering people would tell you this. We do this every day. It's pretty standard what they do. There's nothing new in that. You don't need a HAZOP. You don't need to convene a team for 1 day, 2 days, 3 days to do a HAZOP for that. But there are some other drilling operations. So certain maybe what they call snobbing, activities. Slick line activities, for example, that require you to place to retrofit perhaps a skid on the platform topside to enable you to carry out those operations. So those wouldn't be routine, and you might need to HAZOP that system, particularly the skid that you're bringing on the platform to use for those operations. Yes, you can do a HAZOP on that, and it's going to be. We're going to talk about the types of HAZOP shortly, but it's probably going to be a procedural HAZOP that you do for that sort of thing. Well, combining both the procedural and the continuous HAZOP for that. I'll touch on that soon. Non-routine drilling and workover, I've talked about it. Yes, you will do a HAZOP for that. Review non-process systems, for example, construction, layout, fire and gas systems. That's a definite no. What you would be doing, what you are likely to be requiring for that would be a hazard or some kind of construction risk assessment or quantitative risk analysis and all of that. For change proposals, so change proposals, for those who are not familiar with the term, it's just minor modifications really to plants. So yeah, that's just it. Minor process or plant modifications that don't qualify as projects as such, but still need to be done. Again, that's a maybe. So again, this is what we'll touch on quite significantly in when we talk about the HAZOP decision. I think it's in the next slide or the subsequent 2 slides. But yes, it's a maybe, because sometimes you require to do a HAZOP on those small modifications, and other times you might not. So we'll talk on that. And if you see the notes that I put there, the answer depends on the number of process parameters that are affected, plus the extent of the impact. So the greater the number, the greater the justification for a HAZOP. So refer there to the HAZOP decision matrix, which we'll touch on. So for reviewing ESD system design, yes, you could do that. ESD system, emergency shutdown system design. You could carry out a high level, a course HAZOP to review that, to reveal potential deficiencies in such designs. So on the right here, the bit that I'm just popping up here is just the larger, the wider considerations that would lead you to do a HAZOP. So a HAZOP might be required as a project requirement. So you are doing a sizable, process-based project or modification. You would want to do a HAZOP for that. MOC, that's management of change requirement plant modifications. Again, same as the change proposals. So you may or may not require to do a HAZOP. That's where your HAZOP decision matrix will come in. Come to that shortly. Company requirements. So for example, your 5-yearly plant re-HAZOP. So typically, the plants or platforms carry out a HAZOP of the entire plant. And the reason for that being, over the years, lots of minor modifications would typically have, taken place or been carried out on the plant. And even though those minor modifications, some of them might have been HAZOPed and some not HAZOPed. But what you want to do with the 5-yearly HAZOP or with this HAZOP, the entire plant re-HAZOP, is to look at the aggregate of all of those modifications and make sure that the entire plant in its the plant in its entirety is still safe based on those modifications, because minor tweaks here and there can eventually lead to some latent failures that would eventually if you like, balloon into something, just because no one's looked at that. So typically the plant is looked at as a whole on a 5-yearly basis, roughly speaking. That's the best industry best practice, really, is to do that on a 5-yearly basis. So for that reason alone, you want to re-HAZOP, carry out a HAZOP. So for risk assessment or assurance, so again, as I said earlier, you've done your design, you've done everything. You might be very comfortable with your design and all you've done in terms of its safety, but you just want to do a HAZOP to give people the comfort factor that, okay, this plan. In fact, when an assurance review is being carried out, as is typically the case for projects at the end of projects, question, as I said earlier, is to ask, has it been HAZOP? And that once someone hears, right, the HAZOP's been carried out and completed, everyone just sort of, okay, breathes in and just relaxes. But if there's been no HAZOP carried out, it leaves a bit of, questions. How do we know, how are we sure, sort of thing. So that's what the HAZOP's for. So you've got operability issues with your plants. So a separator or a vessel or whatever is, having issues. You've tried to fix the issues and it's still, coming up, popping up with error messages, giving, funny readings on your level transmitters or any of such things at all. And you can't really get to the bottom of it. Okay, you could decide, all right, let's HAZOP this system all over. Let's HAZOP this system and see if we can nail this issue. It's similar to one of the key reasons for carrying out an FMEA, FMECA, for example. FMECA is very useful for that, although obviously it's not particularly used for for fleet systems as for the HAZOP, but it's for a similar reason as it's used for other systems, just to try and nail down what the issues might be with your plant, operability issues that you might be having. Good. So we come to the HAZOP decision matrix. So what we've done here, what this is a sheet that you use to determine or to decide for yourself if a particular modification, and this applies mostly to the smaller, change proposals, as I mentioned earlier, or MOC, smaller modifications. You've got one of those and you decide, do we need a HAZOP for this? So you are changing out a valve or a PSV, a pressure safety valve. You're changing out, maybe for want of a better example, a biocide package. You're replacing it with a new one. It might be like for like, but you are doing a few piping modifications to enable the new package to fit into that footprint. A few tricks here and there, and you're questioning yourself as the safety engineer for the project. Obviously, you're asking, do we need a HAZOP for this? And so that's how we came up with this matrix. That's basically it's got a set of questions. By the way, can we all see the details of that the text? It's a bit small, the text. I just tried to shoehorn it into the slides here. But if
it's quite blurry on my end, so
it's quite blurry, is it? So what I'm gonna do, actually, if you bear with me a moment, I'll try and bring up the actual sheet itself. Hopefully that's better for everyone. This is not a blank sheet like the other one. This is a bit more, this is populated now. So hopefully you can see the fields that are contained in the decision matrix. So the bits there at the top are normal project stuff. So typically the HAZOP matrix is completed by the responsible, either the process, the safety engineer, whoever the responsible engineer is for making that decision, if you like, for a HAZOP or not to HAZOP. Sometimes it could be the process engineer, depending on the company, or most times, in my experience, it's the safety engineer. And it's checked by the process, the lead, and then, approved by the project engineer. So basically, you review the scope of work that you've got. So that particular modification, what is the scope? What exactly are you going to be changing? And what would be does it result in any change in any of the design parameters, existing design parameters for the plants? So that's what the questions at the bottom here are. So the columns are divided up into A, B, and C. The column A says, there's no change. Column B says the parameter affected by the modification. Parameter is affected by the modification, but conditions remain within existing design limits. And C says the potential for change. There's a potential for change outside design limits, which requires additional design safeguards to be provided as part of the scope. So if you've got that, so if you've got A, so typically you take your modification, go through the parameters that are listed on the left there. So temperature, is the temperature changing? If it's a no, you take an A. If the temperature is changing, but it's still within the design, design temperature limits of the asset, you take B. But if the temperature, for example, is increasing, so your temperature range for that particular system is between 45 degrees C to minimum to 60 degrees C maximum, and your temperature is going to be changing to 65 degrees Celsius. Obviously, you're going to be taking C. If your temperature is going to be changing to 50 degrees Celsius, you want to be taking B. And if your temperature is not changing at all, it remains the same as what the operating temperature is. So for example, if you choose an operating temperature of 47 degrees, that's what you take, so no change there. Likewise, for pressure, it's not changing. Take an A, it's changing, but still within design limits, take a B. If it's changing beyond or above, or even below design limits, you take your C, and then obviously you put your comments in there to say, exactly what is changing. Likewise, flow rates. You would find that when we go over the HAZOP guide words, when we see the HAZOP guide words later, if you're familiar with HAZOP guide words, these, typical HAZOP sort of guide word fonts. Are the physical properties, such as viscosity, changing for the fluid system? No. The second part of that looks at, equipment, either equipment packages or skids that you might be bringing in as part of that modification or that change. Pumps, strainers, compressors are quite large. If you have a compressor system, then you probably wouldn't even need to use this HAZOP decision matrix. You should know right away that you would be doing a HAZOP. But yes, so if you've got new mechanical equipment coming in, typically a pump, you're installing a new pump, right? Does that pump fit within the design, or is it the same design pressure, temperature, or whatever as the existing? Yes. The head and everything, MPSH, are they still the same? Yes, you take your A. So you'll notice with part 2 that there is no option to tick the B part, because it's binary. It's either it's changing or not changing at all if you're dealing with sizable mechanical equipment. So if you've got a new mechanical what this is actually is that if you've got a new mechanical equipment, you should be taking C. If there are changes to the control schemes as the result of that new equipment, you'll be taking C as well. If there aren't any, you'll be taking A. So the second bit, the part 2, the answers are binary. So at the end of that ticking exercise, you tally up your ticks and everything. And what we've said by way of rules of thumb are that if you've got so a HAZOP will not normally be required if the assessment results in entries into column A, only. So if you only take column A, which obviously means there's no changes, obviously you won't need to do a HAZOP. If you've got less than 5 entries in column B, you will not need to do a HAZOP. Obviously, if you've got more than 5 entries, so things are changing, the parameters are changing, but within design limits, if you've got 5 of those or less, you probably won't need to do a HAZOP. But if you've got more than 5 of such changes, you do a HAZOP. And then, of course, if you have any change at all in column C, i.e., for example, your flow rate is definitely changing and it's going above your design flow rate for your system, you want to be doing a HAZOP. You will have to do a HAZOP on that system. So that's what the HAZOP decision matrix is for. And at the end of the day, you decide at the very bottom here, you say, what's your decision? Is a HAZOP required? You've got that, so we take yes. And that for this particular exercise or for this particular sheet, obviously you've got 3 ticks in the C column, so that alone tells you. If you only had 3 ticks in column B, you probably won't need a HAZOP because you needed to have at least 5 ticks in there to do a HAZOP. Now you'd see if you've said no to a HAZOP, there's that note there to consider doing a design review as an alternative. So an opportunity to go over the design just via the P&IDs mostly, of course. So just sitting in a round table, just within the team, you don't need an external facilitator. So this is to be clear on what the difference is between a design review and the HAZOP. For the design review, you're just using the design team. You're not needing an external facilitator to do that, and you're not needing to if you like, it's not as structured or as stringent, the requirements as that. It's just a design exercise, just as you'd have your normal team, design team exercises. But obviously the lead, it's going to be led by the lead engineer for that. Most likely the process engineer, obviously, and the safety engineer. So I've led a few of these, the process engineer, engineers have led them as well. So it just depends. So there's something flashing up there. Okay. So that is the HAZOP decision matrix, and where you decide whether you need a HAZOP or not. Obviously, I think as I've mentioned, depending on the scale or the size of the project or the modification you are dealing with, you probably don't. Sometimes you probably don't even need to refer to this. Sometimes, as a safety engineer, you just know looking at the project. Oh yeah, that's box standard. You need a HAZOP for that. You need to do a HAZOP for that. If you are dealing with more substantial modifications. So this decision matrix is aimed at the smaller modifications where things get a bit sort of nitty-gritty and could fall between the cracks. Just use this to just satisfy yourself that you do or don't need a HAZOP. Because as I said earlier, so if you've got a minor modification, for example, and you're not sure, but then you decide to be on the safe side, a HAZOP is a very onerous exercise. You have to send out meeting invites to, as we'll see later on in the planning and preparation. You do all of those bits, and then you find out when you're sitting in the room that why are we even here at all? Why are we HAZOPing this thing? So you've got an external facilitator whom you're paying quite a lot of money, and he's sitting there wondering, this is all normal design stuff. Why are we doing this? So you don't want to be in that position, because you would have spent quite a bit of money, taken up everyone's time, time that's paid for as well. Hence the reason this decision matrix is quite useful. Right, I'm going to switch back to presentation mode. Okay. Types of HAZOP. Let's go up. Okay. Types of HAZOP. There are basically two types of HAZOP. Touched on that earlier. So and the difference in the types depends on it's the type of the operation or the system that you're dealing with, and obviously the deviations that are applied. That's what distinguishes the two types of HAZOPs. These are first one is a continuous HAZOP, which is the more sort of regular HAZOP that we do. So continuous HAZOP in the sense that you are looking at a system from end to end, either whether it be the entire plant or just the section of the plant, but you're looking at it from one end to from where it starts to where it terminates. That's how you're looking at it. But for the second type of HAZOP, or procedural HAZOP, the batch or the procedural HAZOP, you're looking at an operation, an activity, which is a process activity. So for example, a tank filling operation, manual tank filling operation. It could be a pipeline flushing operation. It could be a plant startup operation, for example. So you're looking at those sorts of things, and what you're HAZOPing is in addition to the actual process that you're HAZOPing, you're also HAZOPing the procedure in terms of the steps that are being taken, and a lot of the human factors aspects, of HAZOPs comes into play during the batch or procedural HAZOPs. It could also even be HAZOPing, as I said, a procedure. So those are the two key types of HAZOP. When we talk later about the HAZOP and do the exercises, the focus is mostly on the continuous HAZOP because those are the more sort of standard ones. But by no means, if you've got any questions or any observations or anything, I'm happy to talk about the procedural HAZOP because I've done quite a few of those as well. Sometimes you use your procedural HAZOP as well. So when you've done a lot of significant plant modifications, and obviously there are operating procedures and operating manuals that are applied to the plants that have been changed. So if a lot of those procedures have been changed, what you want to do is, even though you might have done a HAZOP for your process system, modifications as normal, you then possibly have to do another HAZOP. You do a procedural HAZOP, just taking these, operating procedures and looking at them and HAZOPing them using the appropriate guide words. So again, the guide words for the continuous HAZOP and the batch HAZOP are different, even though they can be mixed and matched sometimes, depending on what you're looking at. Okay, I thought I had something here on the guide words. Show of hands, somebody, if we needed to. I'm just going to go out and take us through some of the guide words. Beg your pardon, I didn't realize I didn't have them in the actual presentation. Okay, HAZOP guide words. So these are the continuous HAZOP guide words. These are the standard guide word and property. So the guide word is no flow, more flow, less flow. We've got the same for pressure, more pressure high, pressure low, typically. Temperature, viscosity, flow, just the same things that we saw in that HAZOP matrix. Less flow, reverse flow, part of or composition change. That's the other way to put that. As well as, so that's contamination, other than. So these are the typical continuous HAZOP guide words that you would have. Have I got the batch ones here? Yes. So guide word. So no. So you're looking at a procedure, for example, and you're looking at a particular activity. So the no is not done, not achieved. You want to open a valve. You're looking to open a manual valve, for example. That's the procedure as part of a startup process. You've opened the valve, but it's maybe it's hooked or not opened fully. You want to crack it. You want to open it 50%. You end up being only able to open it 20%. You press the button for your nitrated valve, and it only opens 10% and all that. So that operation is not done. More in terms of more speed, more often. How often does if you like, if you are flushing a pipeline, for example, how often are you feeding in the flushing fluid or flushing chemical? you're using methanol, say glycol, flushing a pipeline, all that. More activities, how often do you have to start and restart a particular unit? Looking at how much of your material is consumed, rotation, force, and all of those sorts of things. So some of these guide words, obviously, they are very, very generic at this stage. When you are actually doing the your HAZOP, your batch HAZOP, you're looking at the particular steps, each of the steps that you're using to do that particular operation. And you're saying more of that, less of that, too quick, too slow, reverse flow. You see that some of the guide words here as well are I feel like they are repeated from the continuous HAZOP ones. So you can mix and match these guide words, but it's a different kind of, or with different way of applying them for the batch HAZOPs. So that's it, just a quick run through the guide words. Nothing much more to say there. Just switch back to the presentation. Talked about the types of HAZOP. Good. Exercise time for exercise. So how are we set up for the exercise? So we are going to be using the comments box or comments bit, aren't we?
Yes, and if I can just ask you to also maximize it so that, make it a screen so that the main screen so that people can see it, and if everybody can just comment in the comment box.
Okay, am I able to see the comments? So the exercise that we're going to be doing is a HAZOP decision. We are going to be making a decision as to whether or not we need to do a HAZOP. There's two exercises really, to be honest. The first one is we've got on this NAA platform, as I've named it, we've got two 100% gas export coolers. It's a shell and tube heat exchangers, basically, that we've got with export gas on the tube side and cooling water on the shell side. These coolers have a maximum design temperature of 45 degrees C. Take a note on that. And the coolers are significantly degraded and require to be replaced. The solution for that replacement is to design and install 4 new 50% duty heat exchangers to replace the existing heat exchangers. So the modification includes, modifications to pipe work, including the flare system, drains, valves, and flanges. Now, due to the limitations in the cooling water supply, the new coolers will have a maximum design temperature of 65 degrees C. So we are not able to get enough cooling water through the system to get on the shell side of those heat exchangers. So we are going to have to design a system that can take higher temperatures. Basically, that's what that's saying. So, so the temperature has increased to 65 degrees C, and this temperature is at the top end or top range of the export gas temperature specification. So we are hitting the top of our design range. Question is, do we need to do a HAZOP for this or not? Obviously, before we answer that question, have we started to get any responses already with the fast fingers? Okay. A follow-up question that I included with that was to say that given that the existing heat exchangers will be destructed and the new heat exchangers installed in a different configuration. So first of all, we had two 100. So basically we had 2 heat exchangers. Now we are going to be having 4 heat exchangers operating at 50% duty, which if you do the math, obviously it's the same throughput that we are getting because it's still, if you like, 200% capacity that we are still having. Now, those heat exchangers, the existing ones are going to be destructed and removed and replaced with these new ones in a different configuration and with a different footprint, with substantial changes to platform layout. Now, what other kinds of hazard studies might you require to carry out to ensure that all risks are addressed to a lab? That is the exercise that we've got to do, guys. Have we got anyone coming through with comments yet? I need to
able to make it bigger. Yeah, it's definitely clear on my end now. Can everybody see that okay? And can we have answers to, okay, that's fine, thank you. So
Good
does
stuff.
it require a HAZOP? We're getting responses now. It requires a HAZOP. There are going to be changes in the flow rate and also temperature. Yes, it requires a HAZOP. So 3 yeses already.
I'm getting very good answers here. Good stuff, guys. Most people seem to be saying yes. And
for the
good.
additional questions, what kind of HAZOP does it require? Addition.
Someone said here, so Akugi Zibwe, I beg your pardon with that name, Akugi Zibwe has said it requires a HAZOP as there are going to be changes in flow rates and also temperature. I'd be interested to know how you know there's going to be changes in the flow rates, because that's not said there, but obviously it's process person, you might know that. So the answers are mostly yes, yes, yes.
Okay. Cassie, do you want me to unmute Akuzibwe to explain a bit more about? Okay.
Yes, yes. If Akugizibwe. Oh, please, first off, you let me know how to pronounce the name. I'm sorry. Akugizibwe. And if you unmute Akugizibwe, I'm interested to know why he or
I'm trying to find him to unmute him.
Oh, okay.
Yeah, I can.
Okay, good. That's fine.
Just send you a request to unmute yourself. So if you can tell us why you said that answer. You should be able to unmute yourself now because I've disabled that. If you can tell us why you said requires a HAZOP as there is going to be changes in flow rate and also temperature. We're not getting any response for him. I have unmuted him.
Abdulaziz says yes, good. Dinesh says required for temperature. That's correct. Very good. So guys, if you could touch on the next, the second part of that question, which is, given that there's going to be a lot of this structure, remove the existing ones and to replace that with a new configuration and all that, what other kinds of risk assessments might you want to do? So Abdulaziz, yeah, you're helping out Akugi Zebra here. I think changes in flow rate since pipe sizes and valves will have to be changed to fit in the new bigger size heat exchanger. Good, that's a fair answer. Obviously, you need to have done you would have preceded that with the process study to confirm all the flow rates and all the fluid, what's it called now? Okay, guys, I'm not getting any responses for the second part of the question. Are we?
Could you type in your answers if you have answers to the second part of the question, please?
Required for temperature. All right. Good, thanks, Abdulaziz.
Okay, go ahead, Cassie.
Oh, okay, good stuff. So I'm not getting answers to the second part. So the second part there for me, if I was a safety engineer looking after that project, I would be doing a hazard as well, just based on the scale of the changes to the rest of the platform in terms of hazard. The constructability aspect of bringing out the existing heat exchangers, putting the new ones in, all the pipe of modifications and all of that. I'll be doing a hazard generally to see that, check that. The new heat exchangers can be fitted in safely, and impacts to the platform layout are also taken care of. impact to, because we mentioned that the footprint is expanding, it's increasing. So I'll be doing a hazard or a construction type risk assessment for that as well, or a construction risk assessment. I'll do that. So I'll move on to the second example quickly, because we need to take a quick break and then come back to part 2. We are just behind a bit. Switch back to. The second example says the pressure safety valves on the NAB platform required to be removed once every year for recertification. Once again, can everyone see that clearly? Should I?
There's a maximum button there, so maybe you can click that and zoom in.
Say again to you.
I said there's the magnifying glass. If you can click on that, maybe that would.
No, that's just the view.
Just sorry, no. Bear with me. And read. Okay. Can everybody see that question, please? Okay, the answers coming through. Yes. Okay. Hazard identification, basic layout studies. Yes, yes.
Good.
So any more answers for exercise 1B?
So, and that says yes to that.
Yes.
Are these answers to question 1 or question 2? Maybe just clarify for me, guys.
That's question 2.
Okay. Different type of valve is being introduced. So I'm getting yes, yes, and yeses for that one as well.
There's another yes, because it's a different type of valve being introduced. Yes, we're installing a DBB valve, which is done online. Yes. So mostly yeses.
Mostly yeses. Okay. So this is one where you need to refer, I think, to the HAZOP decision matrix. Because if we look at this matrix at the moment, I've just brought up the HAZOP decision matrix. So for that second problem, is the temperature changing? The temperature of the system isn't changing. The pressure isn't changing. Flow rates aren't changing. Level isn't changing. Composition, contaminants, and all of those bits are not changing. Physical properties are not changing. Is new mechanical equipment being fitted? Well, I would say no to that. So a DBB valve, it's just a type of valve, and it doesn't qualify as it's sort of classed under valving, as we call it sometimes. It's valving. It's part of the pipe work almost. So for me, that's not your new mechanical equipment. New mechanical equipment is talking about packages, more sizable bits of kit. So that DBB valve itself is not new mechanical equipment in that sense. So are there changes to the control schemes? No, not for that second example. There's no HPLP interface, and there's no changes to ESD relief and blow down. Well, this is a good question in terms of changes to relief and blow down, but even that is not changing, because all we are doing, the flare system is continuing as it does. All we are doing is installing a valve to enable us isolate that system once every year. So my answer to that, guys, would be unfortunately contrary to most of the ones I'm getting, which would be a no. So I wouldn't do a HAZOP for that particular one. I wouldn't do a HAZOP for the second problem. Okay. What I would do is a design review. I'll just get the guys together and would look at the P&IDs and talk about the system and talk about the changes, and just note down what so the design review. You can just sort of do a mishmash of some of the HAZOP guidelines, just run them through the system, through the process, through the P&IDs, and make notes and Just satisfy yourself that nothing major is changing. So yes, I wouldn't do a HAZOP for that second problem. That would be my opinion for that one, just based on the HAZOP decision matrix. So you see there where the HAZOP decision matrix comes in handy, because as I said, a HAZOP is a very onerous process. You don't want to be doing it when you don't need to do one. Okay, on that note, we'll have a very quick break. I think it might be shorter than 10 minutes. Shall we get back at 1:30, so we can just use 30 minutes to do the remainder? We're not going to take.
Okay, thank you, everyone. We will reconvene again at 1:30.
1:30.
Second part, thank you.